an engine that was everywhere but never got the credit. The Chevrolet 250 Inline Six was the automotive equivalent of a reliable friend, always there when you needed it, never asking for attention, just quietly getting the job done. While muscle cars dominated magazine covers and drag strips, this humble six-cylinder was actually powering America. From 1966 to 1984, the 250 could be found under the hoods of everything from Camaros to work trucks, from postal jeeps to family sedans. It was the engine that delivered your mail, hauled construction materials, and got millions of Americans to work every single day. But here's what makes this story fascinating. The very qualities that made enthusiasts overlook the 250 were exactly what made it brilliant. So why did an engine that was arguably more important to American transportation than any muscle car V8 spend decades in obscurity? And how did hot rodders eventually discover what fleet managers knew all along? The Chevrolet 250 didn't emerge from a clean sheet design. It was born from General Motors' 1962 revolution that swept away decades of automotive tradition. The old stovebolt six-cylinder engine that had served GM since the 1930s was finally being replaced by something called the Turbo Thrift series. This wasn't just an update, it was a complete reimagining of what a six-cylinder engine could be. The new design featured 7 main bearings instead of 4, making it incredibly smooth for a six-cylinder. It was also nearly 100 pounds lighter than its predecessor while being substantially more durable. Most importantly, the bore spacing matched Chevrolet's small block V8, which meant manufacturing efficiency and parts commonality. The 250 variant arrived in 1966 when customers demanded more power from GM's Inline Six platform. Engineers took the existing 230 cubic inch engine and gave it a longer stroke, from 3.25 inches to 3.53 inches, while keeping the same 3.875-inch bore. This created exactly 249.8 cubic inches of displacement, which GM rounded up to 250. The result was an engine that produced 155 horsepower and 235 pound-feet of torque, respectable numbers for 1966, especially in an era when most economy cars were making do with much less. But the 250's real strength wasn't peak power. It was the broad, flat torque curve that made it perfect for real-world driving conditions. By the late 1960s, the Chevrolet 250 had become ubiquitous in American transportation. This wasn't the glamorous ubiquity of a Corvette or Camaro SS. This was the invisible presence that actually kept America moving. The 250 was the base engine in an astonishing variety of vehicles. It powered entry-level Camaros and Novas, providing young buyers with affordable performance potential. It was standard equipment in Chevelle and full-size Chevrolets, giving families reliable transportation. Most importantly, it became the backbone of GM's truck operations, powering everything from half-ton pickups to delivery vans. But the 250's reach extended far beyond General Motors. Other divisions adopted it enthusiastically. It powered Pontiac Firebirds, Buick Specials, and Oldsmobile F-85s. Even the U.S. Postal Service specified the 250 for their Jeep delivery vehicles, recognizing its combination of durability and fuel efficiency. The engine's reputation was built on stories that became legend among fleet operators. Taxi companies reported 250-powered vehicles routinely exceeding 300,000 miles with basic maintenance. Delivery drivers learned to trust the distinctive sound of the straight six, knowing it would start reliably regardless of weather conditions. Perhaps most significantly, the 250 found international success. General Motors began manufacturing the engine in Brazil, where it powered the Chevrolet Opala from 1969 to 1992. Brazilian operators discovered what Americans were learning. The 250 might not be exciting, but it was absolutely dependable. What made the Chevrolet 250 so remarkably reliable wasn't magic. It was methodical engineering focused on longevity rather than peak performance. Every design decision reflected a priority system that put durability first and excitement second. The 7-main bearing crankshaft was the engine's foundation. Unlike many contemporary six-cylinders that used only 4 main bearings, the 250's additional support points dramatically reduced crankshaft flex and bearing loads. This created an exceptionally smooth-running engine that could accumulate enormous mileages without internal wear issues. The long-stroke design, 3.53 inches compared to the 3.25-inch stroke of the smaller 230, was optimized for torque production rather than high RPM capability. This gave the 250 excellent pulling power from idle to about 4,000 RPM, exactly the operating range most drivers actually used. The conservative 8.5-to-1 compression ratio meant the engine could run reliably on regular gasoline while avoiding detonation issues that plagued higher compression engines. In 1975, General Motors introduced an innovative integrated cylinder head design for the 250. Instead of separate intake manifolds, the head and intake were cast as a single unit. This eliminated potential leak points, improved thermal efficiency, and reduced manufacturing costs. The integrated head also optimized the intake port geometry for low-end torque, further enhancing the engine's practical performance characteristics. The firing order of 1-5-3-6-2-4 was specifically chosen to minimize vibration while maximizing power delivery smoothness. Combined with the 7 main bearing design, this created an inline six that was surprisingly refined for such a simple, cost-effective engine. By the mid-1970s, the very qualities that made the Chevrolet 250 so successful in practical applications were becoming liabilities in a changing automotive marketplace. The engine that had been perfectly suited to its era was discovering that eras don't last forever. The most immediate challenge was image. While magazines celebrated big block V8s and exotic imports, the 250 was associated with economy cars and fleet vehicles. Hot rodders looking for performance automatically dismissed inline sixes as inadequate, preferring to swap in small block V8s rather than explore the 6-cylinder's potential. The engine suffered from a perception problem that was largely self-fulfilling. Because enthusiasts ignored it, aftermarket support remained limited. More significantly, the 250's cylinder head design prioritized durability over airflow. The intake and exhaust ports were conservatively sized, and the combustion chamber shape was optimized for reliability rather than efficiency. As one engine expert noted, the heads weren't very good for making power, limiting the engine to about 1.1 horsepower per cubic inch, even with modifications. The fuel crises of the 1970s should have been the 250's moment to shine, but newer technologies were already overtaking it. General Motors was developing sophisticated V6 engines that promised better fuel economy in lighter packages. The Buick 231, Chevrolet 200, and Chevrolet 229 V6 engines could match the 250's fuel efficiency while offering better power-to-weight ratios and more compact packaging. Perhaps most challengingly, the automotive industry was moving toward front-wheel drive architectures. The 250's inline configuration was simply too long for transverse mounting, making it incompatible with the future of automotive design. While the engine excelled in traditional rear-wheel drive applications, the industry was moving in a direction that left no room for long inline engines. The end came gradually, then suddenly. General Motors began phasing out the Chevrolet 250 in the late 1970s, starting with passenger cars in 1979 and finally ending truck applications in 1984. But the decision wasn't made lightly. It represented a fundamental shift in GM's powertrain strategy. The replacement wasn't a single engine, but rather a philosophy change. Base model cars switched to more efficient 4-cylinder engines like the GM Iron Duke, while applications requiring more power migrated to the new 4.3-liter V6. The 4.3 was essentially a Chevrolet 350 V8 with 2 cylinders removed, offering better power-to-weight ratios and more compact packaging than the aging inline six. Fleet operators, who had been the 250's most loyal customers, were initially skeptical. They had learned to trust the 6-cylinder's simplicity and longevity, and many were concerned about the reliability of more complex V6 designs. But GM's marketing emphasized improved fuel economy and reduced emissions. arguments that resonated in an era of increasing regulatory pressure. Corporate average fuel economy standards were also reshaping the industry. Manufacturers needed to meet increasingly strict fleet-wide fuel efficiency targets, and the 250's modest fuel economy numbers were becoming problematic. While the engine delivered decent mileage for its era, typically 13 to 22 miles per gallon depending on application, newer designs promised significant improvements through advanced technologies like electronic fuel injection and computer-controlled engine management. The writing was on the wall in other ways too. Automotive journalists and industry analysts were already questioning the relevance of large inline six-cylinder engines in modern vehicles. The trend toward lighter, more space-efficient powertrains was accelerating, and the 250's traditional virtues of simplicity and durability were being overshadowed by demands for sophistication and efficiency. The transition wasn't entirely smooth. Early 4.3-liter V6 engines had teething problems that made some fleet managers nostalgic for the straightforward reliability of the 250. However, as the V6 matured and electronic engine management systems improved, the advantages of the newer design became undeniable. Interestingly, the 250 story didn't end in North America. General Motors continued manufacturing the engine in Brazil, where it powered passenger cars until 1998 and trucks until 2001. Brazilian engineers even modernized the design, adding multi-point fuel injection, distributorless ignition, and redesigned cylinder heads, modifications that demonstrated the engine's fundamental soundness. By the time the last Brazilian-built 250 rolled off the production line in 2001, the engine had enjoyed a 35-year production run across multiple continents. It was a remarkable achievement for an engine that had never been considered particularly special. Here's where the Chevrolet 250's story takes an unexpected turn. Just as the engine was fading into automotive history, a growing community of hot rodders and enthusiasts began discovering what had been hiding in plain sight all along: genuine performance potential. The revival started with practical considerations. Hot rodders working with limited budgets found that 250 engines were plentiful, cheap, and surprisingly robust. Unlike popular V8s that commanded premium prices, a good 250 could be acquired for the cost of a tank of gas. But what began as economic necessity evolved into genuine appreciation. Modified 250s began appearing at drag strips and car shows with impressive results. Enthusiasts discovered that with proper cylinder headwork, a performance camshaft, and multiple carburetors or a 4-barrel setup, the humble 6-cylinder could produce surprising power. Stories circulated of 250-powered Novas running 120 miles per hour and embarrassing small-block V8 engines from a standing start. The engine's 7-main bearing crankshaft, which had been designed for durability, proved to be an excellent foundation for performance modifications. The long stroke that had created excellent low-end torque characteristics also produced substantial displacement advantages over shorter stroke competitors. Most importantly, nothing sounded quite like an inline six with headers and straight pipes, a distinctive rumble that turned heads at car shows. Modern builds have pushed the 250 well beyond its original specifications. Contemporary enthusiasts regularly achieve over 300 horsepower with extensive modifications, proving that the engine's fundamental architecture was far more capable than its conservative factory tune suggested. Perhaps most significantly, the 250 has found new life in applications where its original virtues remain relevant. Marine installations continue to prize the engine's reliability and smooth operation. Industrial applications value the robust construction and parts availability. Classic truck enthusiasts appreciate the authentic period-correct power delivery and the satisfaction of building something different in a world dominated by small-block Chevrolet swaps. The Chevrolet 250 proved that greatness doesn't always announce itself. Sometimes the best engine is simply the one that works. What do you think? Is there still a place for honest, straightforward engineering? Let us know below and subscribe for more forgotten automotive stories.